Okay, so this is the third part of the probability deal. What is the probability that a family with 5 children has 3 boys and 2 girls? You could make a giant tree diagram, but anytime you're thinking giant tree, you should be thinking what instead? Binomial. I'd like you to just set up the binomial. Don't even put it in the calculator. Set it up for this situation. See if you've got this down. That is right. Okay, and now there is another way you could have set it up. If you didn't want to focus on the boys in the situation, you could have focused on the girls. And then you'd say 5, choose 2 girls. And then this is going to be girls, and this is going to be boys. Still a 50-50 of that. Then 2 girls means 2 of those, and then 3 of these. All that changed is that I switched around these 2. And this and this are different. But what do you know? If I told you that those are the same exact answer, what do you know about these 2? They're equal to each other. And that's counterintuitive. A lot of people think, well, 5 choose 3 has got to be different than 5 choose 2. But it's not. If you figure out the value of something like 5 choose 1, no, 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, etc. It'll go up. What's 5 choose 0? How many ways can you choose nothing? There's one way you could choose nothing. Get the idea? My choice is nothing. That's a choice. There's one way to do that. So that would be 1. Versus 5 choose 1 would be 5. And then 5 choose 2 would be, and then it goes up like this. And then it comes back down again. I wish I had drawn my graph bigger. Okay. Anyway, by the end, it gets back down to 1 again. Because if I do 5 choose 5, 5 choose 5 has only one way to do it. So it's one of these things that kind of makes a curve like, ooh, like that. So these 2 are equal. 5 choose 3 and 5 choose 2 are exactly like here and here. They're the same height because they're the same value. All right, moving on. Baseball coach is determining the batting order for the team. The team has 9 members. This is one of those where you don't want to use any of the other methods. You want to use blanks. Because it's got a weird situation. He doesn't want the pitcher to be one of the first 4 to bat. Then you can take these 4 and they'll be all different. Instead of 9 choices, what should we start with? 8 choices here, and then 7, 6, 5, and then here there would normally drop off to 4 choices, but now we can add the pitcher back in, so 5 and then 4, 3, 2, 1. Get the idea? And that's one you couldn't do with other methods real easily. You could do it, but not easily. Okay. Let's talk about, that's basically expected value on number 13 there. We've done enough of those. This is a good problem. 4 seeds are planted, each one having an 80% chance of germinating. What's the probability at least, we haven't talked about that yet, 1 will germinate? If at least 1 was going to germinate, then it could be 1, or it could be 2, or it could be 3, or it could be 4. So you either have to figure out the probability of 1, 2, 3, and 4 things germinating, and then it's this, or this, or this, or this, and or means add them all up. Or I could do it smarter. Do you remember what to do? Sid remembers. Yes, find this one. 1 minus that one. So the probability of none of them germinating would be C, and then a couple parentheses, and these are 80 and 20. And then I have 4 seeds, and I want 0 to germinate. 0 do the 0.8, and then 4 do that. And you'd figure that answer out and take 1 minus that answer. Or I could figure out this answer and this and this and this, and then add them all up. That works too. A lot slower. Okay, we're almost done. If things can repeat, like letters in a license plate, then use blanks, not P's or C's. Because if you use P's or C's, P's and C's are assuming that your numbers go like this, 5 times 4 times 3 times 2. They're based on those. And if things can repeat like license plates, then you could say, well, there's 10 choices, and there's 10 choices of number, and there's 10 choices of number, and then there's one letter, and there's 26 choices of that. these could all be repeats, so they don't go down like they're like your other math problems are expecting them to, or your methods. So use blanks for like license plates. And this is a card problem example. How many cards were you dealt? Can you tell? 5. Out of how many cards were there? 52. And I wanted 4 out of 4 of something. What if you're playing cards, what's a good card to get? Like an ace. So I wanted 4 aces, and then what's this thing mean? One of the other cards. Exactly. The one things that aren't aces. All right. See if you can set this one up. I want 3 queens and 2 kings out of 5 cards that I get dealt. See if you can set me up. Set it up for me. And yes, I was dealt 5 cards. And you've got it right. Nice work. Okay. Well, there's a lot to know in probability. This is definitely one of those areas that you ought to spend some time studying. The practice problems that I'm giving you, I want you to do 1 through 21 today. Problems 1 through 21.